Okay, in this video, let's talk about this question here, the ammonia production. So one way to make ammonia on an industrial scale is to react nitrogen monoxide, NO, plus hydrogen, H2. Water is a byproduct. What that means is water is another one of the products in addition to ammonia. So you'll need that to set up your equation. The question is asking us how much ammonia can we make when 27 grams nitrogen monoxide is reacted with 5 grams of hydrogen. So this is a sort of limiting reagent problem. We've got two reactants. I've given you how much of each you have. Given that, how much can we make? So let's walk through this together. Of course, the first step is to come up with the chemical equation. NO plus H2 gives NH3 plus H2O. Again, remember, water was a byproduct, so we know that's on the product side. Next step, we have to balance this equation. Go ahead and try and balance that. Pause the video and unpause it when you think you have it balanced. So we get 2 moles of NO reacting with 5 moles of hydrogen to give 2 moles of ammonia and 2 moles of water. So now we have all the different possible conversion factors we could need. So we've got two separate starting materials though. The way to do this problem is to just treat each of them separate. So starting with the 27 grams NO, how much ammonia could we make? So in essence, we're assuming hydrogen is not an issue. We're assuming we've got all the hydrogen we need. So based on just the NO, how much could we make? So we just convert grams of NO to moles of NO, moles of NO to moles of ammonia using the mole ratio in the equation, which in this case is just 2 to 2, and then convert moles of ammonia to grams of ammonia. So pause the video and see if you can do that and get the same answer I got. Did you get 15.3 grams ammonia? Okay. Now, we're not done yet because that calculation we just did assumed we have plenty of hydrogen. But there are two starting materials in this reaction. It's like doing a recipe and you might have tons and tons of chocolate chips, but if you don't have any sugar, well, it doesn't really matter how many chocolate chips you have. So we have to look at both starting materials. So we do the same calculation, but starting from the 5 grams of hydrogen. So take a minute, pause the video, and figure out how much ammonia could be made starting from 5 grams of hydrogen. And when you're done, unpause the video and see if you got the same answer. Did you get 16.9 grams ammonia? Okay, so what does it mean? We've got two amounts of ammonia. Which one is right? What do we do now? Well, some people will say we add them together. Don't do that. Okay, this is a limiting reagent problem. It's like a recipe. Okay? What we have just found out is that we have enough nitrogen monoxide to make 15.3 grams of ammonia. We've got enough hydrogen to make 16.9 grams of ammonia. Therefore, we only have enough starting material to make 15.3 grams of ammonia. So we say that NO, nitrogen monoxide, is our limiting reagent, and we can make 15.3 grams. Okay? It doesn't matter that we have enough hydrogen to make even more. We've run out of the other ingredient. It's like you're making chocolate chip cookies, and it doesn't matter if you've got a garage full of chocolate chips if you've run out of the other ingredients. NO was limiting in this case. So the thing to keep in mind here is you have to do both of these calculations to figure out the final answer. It's not enough just to look at how much starting material you've got here. Notice we only had 5 grams of hydrogen. We had 27 grams of nitrogen monoxide. And yet we found that nitrogen monoxide was the limiting reagent, even though we have a lot more of it on a gram basis. So you have to do both calculations, or for all of the starting materials, in this case there were only 2, and then figure out which one is limiting, okay? So the calculation here on the bottom is a meaningless number now because we don't have enough NO to make that amount of ammonia, but we had to do the calculation in order to find that out. Okay? Now, in terms of sig figs, we would report our answer as 15 grams of ammonia because we only had 27 grams of nitrogen monoxide. So 2 sig figs, that converts to 2 sig figs. Okay, remember these mole ratios are infinite. This isn't saying about 2 moles of NO makes about 2 moles of ammonia. Those are exact numbers. So the 2 moles of ammonia and 2 moles NO treat as having infinite sig figs. Okay. So I'll stop there and make another video for some other problems.